If you want to get into data science, one of the most crucial skills that you need to pick up is knowing how to choose and validate your models. So the commenter here was talking about experimentation, and I'm going to get to that. But in general, this goes whether you're talking about causal inference or machine learning or really doing any sort of predictive model. So you're probably familiar with the concept in machine learning of splitting your data into a testing and a training data set. You get the model on the training data set and then you test it on the test data set. And the reason this works is because in the test data set, you have labeled data. You know what the true answers are, and you can see how well your predictions match up against that. Now, in the causal inference and experimentation world, things are a little bit different. We don't have labeled data that says there's a 5% increase when we have this exact type of treatment. So usually what we do is, and y'all, if you want to get into this field of data science, this is one of the most important elements that you're gonna hear. Typically, you're gonna validate the data sometime on pre-treatment data. So if you have observational study, there is at some point where there's a post-treatment period, you want to validate your model on whatever time period it is before the treatment started. Similarly, if you are designing an experiment, you have a whole host of time, basically up until the present day, of untreated data. So if I was trying to decide between a switchback experiment where you're sort of randomizing or alternating on-off treatment on, treatment off, or a geo experiment where you have some geographic areas that are going to get treated and some that are not, I would test both of these models and see which one is consistently giving me results that are close to zero. Effectively, that would be unbiased. And then whichever one performs better, that's the one that I would use or design for the actual treatment itself.